Ever wondered why humans, among all the creatures on Earth, have the most complex brain? This intricate organ, with its billions of neurons and trillions of connections, is the epicenter of our thoughts, emotions, and consciousness. It's what makes us capable of creating art, constructing languages, and solving complex mathematical problems. It's what makes us dream, love, laugh, and learn. It's what separates us from other species and gives us our unique human experience. The brain indeed remains one of the last frontiers of science, full of mysteries waiting to be unraveled. As our curiosity about the brain deepened, so did our need for innovative ways to study it. The evolution of neurotechnology has been a fascinating journey, one that has transformed the way we interact with the human nervous system. In the early stages, rudimentary techniques were all we had. These basic methods, however, were crucial stepping stones, paving the way for the advanced technologies we have today. As we delve deeper into the brain's intricate workings, we realized the need for more sophisticated tools that could help us monitor and modulate neural activity. This need sparked the advent of electronic devices that could interact directly with the nervous system. Deep brain stimulation, for instance, became a groundbreaking technique used for treating neurological disorders like Parkinson's disease. By sending electrical impulses to specific parts of the brain, this technology offered a ray of hope for those grappling with such conditions. But our quest to understand the brain didn't stop there. As our technological prowess grew, so did our ambition. We began developing technologies like transcranial magnetic stimulation and neurostimulation techniques such as transcranial direct current stimulation. These non-invasive methods allowed us to modulate brain activity, opening up new avenues for research and therapy. Yet, the most revolutionary development in neurotechnology has arguably been the brain-computer interface. This technology has blurred the lines between man and machine, enabling direct communication between the brain and external devices. Imagine controlling a computer or a prosthetic limb with just your thoughts. That's the power of brain-computer interfaces. These advancements in neurotechnology have not only deepened our understanding of the brain's complexities, but have also provided us with novel ways to address neurological disorders. We've moved beyond mere comprehension to a point where we can actually modulate brain activity, offering new rehabilitation methods for those with neurological problems. With advancements in neurotechnology, we are not just understanding the brain better, but also exploring ways to repair neurological disorders. Our journey through the evolution of neurotechnology is far from over, but as we continue to push the boundaries of what's possible, there's no telling what the future holds. As we stand at the precipice of a new era, neurotechnology promises to revolutionize not just science, but also our daily lives. It is a field bursting with the potential to transform the way we understand and interact with our own minds. Imagine a world where neurotech applications can be used to treat neurological disorders, offering new hope to those who suffer from conditions like Parkinson's or Alzheimer's. These technologies, such as deep brain stimulation and transcranial magnetic stimulation, are already being used to great effect in the clinical field. But the potential of neurotechnology stretches far beyond the medical realm. Let's consider its economic implications. As neurotech continues to evolve, it gives rise to a whole new industry, brimming with opportunities for innovation and growth. It's a sector that's expected to generate billions, if not trillions of dollars in the years to come. One of the most exciting developments in the field is the concept of brain-computer interfaces. It's a technology that can make sci-fi dreams a reality, allowing our brains to interact directly with electronic devices. Imagine controlling your computer or smartphone with just your thoughts. Even more tantalizing is the concept of mind uploading. It's the idea of copying our consciousness onto a digital platform, effectively achieving a form of digital immortality. It sounds like something straight out of a futuristic novel, doesn't it? The future of neurotechnology is indeed exciting, but it doesn't come without challenges. As we stride forward, we must ensure that we navigate this new terrain with caution, always keeping in mind the ethical implications of these advancements. But that's a discussion for another time. Stay tuned. As we push the boundaries of what's possible with neurotechnology, it's crucial that we ponder the ethical implications. In our quest to decode the human brain and amplify its capabilities, we're venturing into uncharted territory. This presents a set of ethical challenges that are as complex as the brain itself. Firstly, the question of identity. Neurotechnology has the potential to alter our neural activity, which could change our thoughts, emotions, and behaviors. But to what extent can we modify our brains before we cease to be ourselves? The issue of agency also arises. If our actions can be influenced by a brain-computer interface, who is truly in control, us or the technology? This brings us to cognitive liberty. Should we have the right to control our own mental processes, or can these be manipulated for therapeutic or enhancement purposes? Lastly, privacy. Our neural data could reveal our deepest thoughts and feelings. How do we protect this information from being misused or exploited? These questions underscore the need for robust regulatory frameworks. It's imperative to ensure that neurotechnology is used responsibly, with respect for individual rights and dignity. As we step into the future, the challenge lies not just in advancing neurotechnology, but also in navigating the ethical maze that comes with it.